If you have a Mac Mini, no matter whether it's the shiny new M4 or M1, M2, if you want to get faster network speed, more than 1 gigabit, you either spend $100 more when you purchase your unit to upgrade the RJ45 to 10 gigabit, or you spend even more later to buy a external adapter to achieve 10 gigabit. But in this video, let me talk about a cheaper alternative way. You can get two dirt cheap 2.5 gigabit network adapters. It doesn't matter whether the other end is USB-C or USB-A. That's why in this video, I'm going to use two different USB types. You plug them in to the correct USB port. Then you have two separate 2.5 gigabit network interfaces, right? In this test environment, I have a unified 8-port switch, support 2.5 gigabit. I also have two ports, they support 10 gigabit. So I connect 3 Mac computers. The one in the middle is the one I connected to adapters. The other two, one of them support 2.5 gigabit. The other one is connected to the 10 gigabit port. So in this environment, let's test how the network performance look like for this Mac Mini in the middle. So in the lower right of the screen, you can see this Mac Mini computer. In the network setting at this moment, you can see both the USB adapters, they are showing active. So at this moment, I have two active 2.5 gigabit network connection. But this is not what I want. What I want is to set up link aggregation so that I can have a single 5 gigabit connection. So in macOS, to set up link aggregation, you go to Settings Network, scroll to the end, see this button with 3 dots, click on the Manage Virtual Interfaces. Then we can add one. Choose the new link aggregation. To make the link aggregation work, all the participating interfaces, they should have the same link speed. So here I only select the two USB adapters. Create. Done. So that's how easy it is in macOS to enable the link aggregation. But after enabling it, you can see the original two USB connections, they are gone. Now I end up with this one. It's called untitled bound. Then it's showing not connected. Why is that? Because just changing the network setting in the Mac Mini is not enough. You also need to change the setting in the switch side accordingly. So here, let me show you the network controller from Ubiquiti. So for this particular switch, as you can see, the port 7 and 8, they are showing the light blue color, which means it's 2.5 gigabit. They are both showing connected to the Mac Mini. Then if I click port 7, go to menu, for operation, let me choose aggregation, then aggregated port from 7 to 8, then apply changes. Okay, so now the link aggregation is enabled in both ends, the switch and in Mac Mini. Give it some time. In macOS, the bound interface should be showing active. Okay, you can see now it's showing green color. This is our bound interface. It should have the aggregated 5 gigabit speed. Let's test it. First, test it against the other Mac machine which has 10 gigabit network. And this Mac computer is connected to the port 9. From the color, you can see it's 10 gigabit. Now let's test the network speed. One thing you may know, the way link aggregation works is it's not simply end up with a 5 gigabit connection. You can think of if you are doing two different tasks. For example, you are doing the file transfer between your computer and your NAS, and then at the same time you are doing, let's say, some internet download, right? You are doing two different network tasks. If that's the case, the system can utilize the aggregated bound interface to do the two things. But if you are only doing one thing, for example, you are copying file from your NAS, you cannot expect you get 5 gigabit network speed because the system cannot really distribute the same task to the two different bounded physical interfaces. So that's one thing you need to be aware of. Otherwise, you may be disappointed about the testing result. So from the switch, you can see this port 9 is connected to the 10 gigabit Mac machine, and this port 1 is showing light blue color, is 2.5 gigabit, is connected to another Mac machine. Let's start the first test. Let me test the speed between these two computers and these two computers at the same time so that we can see the aggregated total network speed. I'm going to use iPerf3 to test the speed. So from the other two Mac machines, let me start iPerf3 server. Okay, started. Then from this Mac machine, which has the aggregated 5 gigabit network bound interface, let's start the testing. So in the two separate terminals, the left side terminal testing against the 10 gigabit machine. This time I'm testing the default direction, which is uploading. Okay, started. In the second terminal, test against the 2.5 gigabit Mac, started. Okay, we are lucky because the very first try already shows you the negative part of the aggregation, because you can see the total speed is 2.5 gigabit instead of 5. Why is that? Because the system is not smart enough. It happens to use the same physical link for the two testing sessions. However, if I start from scratch, try again, in the right side, run the exact same command again. You can see close to 2.5 gigabit speed, right? You can see the two testings are in progress in parallel, which means in total, I have the almost 5 gigabit uploading going on, right? Kill them. Then this time, let me test another direction, which is receiving or downloading. Specify the same -r parameter. Start the first one. Okay, similar situation, close to 2.5. Let me run similar command. The direction is receiving or downloading against the 2.5 gigabit machine. Run it. Okay, so you see the same good result, right? We can achieve close to 5 gigabit downloading speed if we add these two sessions together, right? So we are good about the separate speed testing. Next, let's test both directions. Let me specify --by direction, which means it will do the download and upload at the same time. Start it. You can see the receiving speed is not very good, only close to 2 gigabit connection. So maybe it's due to the quality of the adapter. In the right side terminal, let me run similar command for both direction by dir. Run it. In total, for transmitting or uploading, the speed is still very good. The total speed is about 5 gigabit, but for downloading or receiving, the speed in total is close to 2 gigabit, not 5 gigabit, right? So we see a problem this time when we test the bi-direction. For downloading, the speed is not very good. Again, this is due to the way how link aggregation works. So when we start the left side terminal connection first, of course, the system has all the resources to be used by this testing, right? But when you start the second one, sometimes the system may not be smart enough. It will still choose the same physical link. That's why here you can see the total downloading speed is close to 2.5. It's very possible the system is using the same physical link to do that. To confirm that's the case, let me run the command in another way. So let me use this parameter, -p10. I will run 10 parallel connections. So which means there are 10 internal testings going on in parallel. The system should be able to distribute all the loads to the two physical links evenly. So let's validate that's the case. Start it. Okay. we can see interesting result. This one is the summary for transmitting. This one is the summary for receiving. You can see both of them are close to 5 gigabit. So now we are not even using this 2.5 gigabit Mac machine. We are only testing against this 10 gigabit. We are already reaching almost the physical limitation for both upload and download. Why is that? The reason is we specified -P10, which means we don't have to use the right side terminal. Just the first side terminal should already be enough to saturate the physical two links. The system should be able to distribute the 10 loads to the two physical links. Okay, so I'm good with this testing result. We tested separate connections from this middle Mac machine to the left one and to the right one in parallel. And when we only test uploading, good. Only test downloading, good. But when we test the speeds together, we observe sometimes the aggregated speed is only 2.5 gigabit instead of 5. And as I explained, and then as I confirmed using the -P10 parameter, that's simply because the system happened to use the same physical link for the testing. But after we specify the -P10, we have enough parallel tasks going on, so the system was able to distribute the load evenly. To translate this situation to real world, only when you have multiple tasks which are network related and you can do them in parallel, you may see the consistent benefit by aggregating your two physical links in this way. Otherwise, sometimes you may see improvement, sometimes you will only see the speed for original one physical link. It's simply because of how link aggregation works. Okay, this is the end for the video. Thanks for watching.